Good afternoon, everyone. It is now afternoon on the East Coast. Is the OSI Economics Interest Group, August 12th. We got some good talks, good conversations we had about markup languages in economics. High level stuff for the group. I'm thinking about it. There really isn't much. Anyone listening to this on the recording, if you want to get involved with this, go to opensource.science, scroll down, you'll find all the interest groups that we host, find the economics one, join that group. You'll get email notifications whenever we're going. The goal here is to connect open source software and the developers of open source software to the people using that software for scientific research.
Well,
That said, to answer Sebastian's questions, no, we don't like cameras. You're welcome to use a camera. I'm not a fan.
it's been a bit of a mix. I think it's trended towards off. A lot of the times people are eating. I mean, it's a noon call for people on the East Coast. I think rather than make people feel like they have to be on, we've kind of trended towards the camera off. Sometimes the speaker will be on. I think that makes sense. I think I tend to want to be on if I'm the speaker, but I think it'll be an interesting experiment in its own right. See if it's how sticky it is. I wanted to make one more comment before we get going, which is that we are looking for more suggestions for topics and speakers. Feel free to reach out to John, myself, Philip, or Alan if you're interested in having a conversation about whether or not a topic would be relevant. And hopefully we'll continue to get folks joining and both participating as well as presenting in these sessions there once a month. And with that, I think we can go to Seb.
Hi, thanks for inviting me to talk about this. And I see a variety of comrades and colleagues here, some of I've met before, some of which I work closely on Econ, which is largely responsible for what I'm presenting today. So I'm here to discuss perhaps a new markup language for economic models. And I've got a question mark there, mostly about the use of the term markup language, but we'll get into exactly why that nuance may or may not controversial.
I was wondering about that. So I'm glad we're going to discuss it. It's an interesting twist. So I'm looking forward to that.
Okay, great. So I wanted to discuss very briefly a history of economic domain-specific languages. And I'll preface this by saying I'm not an economist, unlike several people in the room, and I fully expect to be interrupted and corrected. And then I want to discuss work that Econ has been doing towards developing a kind of model language as an evolution of these earlier ones. I want to start with a slide with too much text, but talk kind of about structural modeling in economics as I have come to understand it, just kind of set up what the problem is. So there's a variety of different fields that do some kind of modeling with equations, often called structural equations. And these don't have to necessarily even be in the social sciences. You can model anything with equations. And these can be dynamic models, meaning there's some kind of recurrence over time. They can be stochastic, meaning there's randomness in it. And then there's another field, which is kind of in the sort of orbit here, called agent-based modeling, which is a form of computational modeling where there's many different agents and they're typically defined in software. So the emphasis is much less on having explicit equations and much more on sort of having a realistic simulation of what's going on. This gets used in sociology and epidemiology, many fields. Civil engineering sometimes uses agent modeling. My understanding is that economic modeling typically involves agents that are doing some kind of rational utility optimization. And that this is part of what's special about structural modeling in economics. And And because it includes this optimization step, which might be boundedly rational or something, it makes it more complicated to solve the models. Like so with a model where the agents are zero intelligence agents, they're just operating according to programmatic rules, there isn't a step where you have to figure out what are the agents' actions or strategies or decision rules. In economic modeling, you have to do that. There's a step where you solve the model. Solving means figuring out what are the agents' sort of best strategy in the game, and then you play the game out with the simulation. Okay. And it gets even more complicated when these strategies are in strategic equilibrium. That becomes computationally even harder. And so having a very well-defined model is important for setting up the optimization problem. And it's where it introduces a lot of the complexity here. So one of the first groups of people to try to do this, in my understanding, developed something called a general algebraic modeling system, known as GAMS, which is still being sold. It started in the 1970s, but it's still being sold as a proprietary optimization library. And it provides a domain-specific language for writing up linear, nonlinear, mixed integer optimization problems. And it's widely used in economics, especially in computable general equilibrium modeling, which is used by places like the World Bank to look at the potential impact of introduction of new tariffs and other kinds of trade-related models. A lot of people now are saying that it's easy to do CGE modeling in Julia, which is it's a programming language in its own right. So I don't have a lot on Julia here, but this is a sense in which the tide is shifting. There are other proprietary systems that have been used for this kind of modeling. MATLAB used to be using it. You wouldn't necessarily call it an optimization language, but to some extent, the open source tide has been rising, and there's room for an open source intervention here. What I'd say maybe the most widely used open source economics modeling DSL that I know about is Dynair, which is specifically for macroeconomic dynamic stochastic general equilibrium models. It's very limited to the representative agent case. That means taking a whole sector of society, like all consumers, and representing them as a single agent, which is a move that has been, it used to be necessary for analytic and computational tractability reasons, and as it becomes less necessary and is shown to be more and more unrealistic, people are moving away. So this is a domain-specific language with a C++ preprocessor. It's portable into a bunch of different fields. It's open source now, but somewhat limited. And things have changed since Dynair was open source in the year 2000. One is that this dynamic stochastic general equilibrium and representative agent paradigm has been challenged by the facts of things like the Great Financial Crisis. And also, so much has changed about how we compute things. We have fast Python, Julia, GPU programming, open source workflows are now widely understood and even normal. Jupyter notebooks are a thing. There's deep learning approaches that make it feasible to solve models that weren't solved before. So there's a lot changing. One thing that's changing is this move away from representative agent modeling towards heterogeneous agent modeling, which means that rather than identifying, saying this whole sector of the economy, all consumers, are a single agent solving one optimization problem, you can have a whole population of heterogeneous, different agents, each solving problems that are specific to their situation. Now, the problem is with these models is that since they can be so much more expressive, they can be much more complicated, much higher dimensional state spaces, shock spaces. And so the computational complexity of this optimizations that need to be done to solve these models are higher. So this is created a puzzle. It's part of the reason why there isn't already a solution to this, because methods are kind of catching up to the space of possible expression here. But we all also are on the period where there's a lot of creativity in new methods. So to some extent, all this complexity is hitting the field of economics and is creating a reproducibility crisis, because since everybody is implementing their own bespoke heterogeneous agent models, it's hard to compare results.
So there's a little, I want to make a poke here though, where I think this is very common for economics, is like, from my perspective as a controls engineer, is that like methods percolate from robotics and elsewhere. And the thing that you do with this is, in your structural model, you make sure that your world is meaningfully distributed so that you have limits on observability and controllability, and an individual agent within a landscape that you're building isn't actually trying to solve a problem with awareness. And this is related to the bounded rationality, but it's more like structurally bounded than not that just that they can't think through everything, but they have a limited set of observable signals. They have a limited set of controllable ones, and they can be affected by agents that are distant from them in the sort of causal graph structure. But it seems to me that like what's happening is that although lots of different people are building different frameworks, the thing that makes it like mathematically or kind of formally tractable is to do work on the structural modeling layer to represent the system's actual information, distributed kind of information partition, who knows what, who can do what. And so you can get potentially relatively rich world environments that don't have the computational complexity that would emerge from having the individual agents, representative, subpopulation, or otherwise, trying to solve the whole optimization problem. They're like sort of local to their observable and controllable signals, again, embedded in a microstructure. And this is how we've been doing multi-agent robotics problems for at least since I was in school, 20 years ago. And it seems to me that that's bubbling into the economics discipline nowish. I don't know if that is consistent with your observations, Seb.
So let me speak to that, because I have the longest history in all of this sort of stuff. I think, first of all, that was a very nice articulation of the structure of the kinds of problems and where we stand. It is still the case that the default requirement for getting your paper published in a top journal is usually that the behavior of the agents is consistent with what it will be if they understand every last aspect of the entire gigantic system and all of the actions within it. It's the sort of breakthrough tricks that have caused heterogeneous agent macroeconomics to become publishable involve realizations that actually, if everyone is interacting through a market mechanism, and then all they really need to know in order to predict the future is some characteristics of the current state of the aggregate. And so that is a sufficient statistic, so to speak, for all of the underlying details under certain sets of conditions that are, of course, absurd. But we haven't given up as much as you seem to think on the requirement that the agents behave in ways that that effectively reflect an understanding of the entire system that they live in. It's just that we've figured out ways to make that a simple enough problem that doesn't make it impossible to solve the models.
I think that makes sense. I think maybe the big split there was where at the beginning you were talking about what's required to get something published. So I'm operating both from the robotics and from the like mathematical ontology and the industry viewpoint, where I'm having to do more like market design or like institutional structures, kind of institutional grammar, ask who can do what under what circumstances with kind of reachability analysis and failure mode. modes, and those models are actually much more closely related to the robotics things that I was associating to, because I'm not, to be blunt, like I'm not trying to get something published, but I think what's interesting here is that those two things kind of weave against each other. So I'm very curious. I'll let it go. But
Well,
I
I'm
think
really
that was a big difference.
I'm really enjoying your perspective. It's very interesting. Just I was expecting to say justify, but I don't really think it's justified, to explain our focus on the solution that you would get if everybody understood everything. The problem is that if you deviate from that, there's like an infinite number of ways to deviate from it, and there's not a consensus on what deviations are justifiable and which ones.
100% with you. I mean, this is actually, to be fair, I think the kernel of why I think this open source community is interesting, because the practice of, let's call it, I'll call it engineering, but design in general involves commensurating the incommensurable to some extent, being like, we have some requirements, like there's no right answer, but we got to pick one, and then we need to justify it. And so we're like moving into a realm where I think the open source software development and open source economics community may have to do that work to figure out what that looks like, because it's not clear that the academic institutions are incentivized to do that.
Yes, or the academic individuals. But yes, okay. So let's let Seb go on.
Yeah, I guess my comment is, being someone who doesn't typically try to publish economics articles, argument, I'm like, yeah, I get it. I think some aspects of the bounded rationality issue can be done based on the structure of what people know, but there still is a question, since a lot of these are sort of dynamic models. There's some kind of equilibrium analysis where even what people are exposed to might be distributed in a way that's sensitive to the actions of the individual people in it. So I think this gets into like lots of different technical details and lots of different things you might want to try to express with this kind of language. And like, I agree with you that the things you're talking about are exactly the sorts of things that should be expressible, and those reachability things should be exploited by the solution architecture. But what we're talking about here is partly, how do you even define the problem that might be solved, even if we know that it can only be solved in an approximate way? Like, what are the contours of the problem, leaving almost aside how to solve it?
Yeah.
So just a next point here, Pablo Winant, friend of Econ, great human being, very smart person, has developed Dolo, which is a kind of take on Dynair, but for other kinds of problems, especially in macroeconomics. And an innovation of Dolo is that there's this YAML-based configuration language that then gets interpreted by, there's kind of an engine in Python and Julia that interpret the language and sort of compile it, or actually, I'm not sure what it does in Julia. In Python, it parses the language and then interprets it into things that are Python objects, and then uses those Python objects with GPU or number optimizations in order to solve them. It has a particular sort of constrained subset of the economic problems that might be used to solve. It's in its most basic version, it doesn't do market aggregation, it doesn't do aging and mortality, but it's a great example of what can be done with open source tools, sort of patching together something that looks like a DSL for modeling. And then another kind of thing, which is not a modeling language, but a library that is being used in economics, the one well represented here by the Econ team, is sort of HARP, which is in its kind of 0th iteration right now, which is it's in Python, and it can do a wider range of problems. So it can model cases where a population of agents ages and dies and is born over time, which is very important if you're trying to model like an economy at equilibrium, and you're trying to deal with things like health shocks, or people earning different amounts of income over the course of their life and then retiring. And it does do market aggregation, which is one of the sort of fundamental contributions or anchors of macroeconomic modeling. And that's where we get into this issue of are the agents responding to market aggregates that are themselves at equilibrium? But there's a few limitations of this sort of HARC 0.x version. There's a lot of sort of handcrafted code in it. The models inherit from each other in an object-oriented way. There isn't a single source of truth of model information. And this is something that we are at the moment moving away from towards a different kinds of paradigm in order to think about how to implement a modeling language, where sort of HARC 1 might be a reference implementation for such a language.
Do you make strong distinctions between what are effectively, software architecture related requirements and kind of behavioral requirements? Because it seems like in your last description here that there's a little bit of a blending of like the logical components, like say kind of agent behavior related to, again, whatever information they have access to, whether it's everything or a subset. And what they can do is like it's kind of behavioral. It's like I can see this and I can do that. Therefore, I do it according to these kinds of optimizations, even if they're imperfect or approximate. That's a description, a functional or behavioral description, versus something like a software language, which provides you affordances for implementing logical components that represent, say, computing and executing behavior, resolving the consequences of those actions potentially with multiple actors in parallel, et cetera. Like there's a kind of almost a pretty rigid difference between, requirements expressed in terms of what is implementable and how it's implemented versus the kinds of behaviors that exist within a simulation, or are the kinds of things that you want to do once you have one. I don't want to go off on too far of a tangent. I'm still kind of understanding the scope of the design problem that you're expressing here. It seems it's more on the behavioral side, like moving away from the.
Well, no, not exactly. So that's I'm really enjoying your perspective. So the way things are done is that you write your paper for the academic journal, and in that paper you are describing the the sort of high level math of an optimization problem that the consumer wants to maximize utility or whatever. And then you have maybe a little bit more about how you manipulate that model in order to turn it into implications for computable objects. But then when you implement it in code, there's no requirement that the code have any, fidelity from top to bottom with the mathematical sort of conceptual basis that it's coming from, the optimization problem. So you might derive some equation that tells you that the coefficients on certain variables will be equal to certain parameter values, and you just like hardwire that into the code without much explanation or comments or any sense of obligation to say, like, where did this come from? Oh, it comes from Appendix 4, unpublished Appendix 4 online on.
Well, that makes total sense. But so then that's a point of poking for me, which is like,
Yep.
in my experience, again, like robotics engineering hat, those things are actually really important to pull into the front because they're the things that you vary in a robust optimization sense. Like you're like, okay, cool. Like, I assumed all this stuff, but now I need to be like, but what if it's not that? What if it's this? What if it's this? And so not only calling it out, but also giving it a kind of intentional vagueness where you're like, well, we could have assumed it this way or that way. And so when you create that, you're effectively defining the dimensions of your it's not just your Monte Carlo, but like I would call this kind of your assumptions. Maybe there's some parameters of your world model, because in principle, agents take actions with, when you say you make it computational, you have there observation and decision spaces, but then you also have the ways in which the world computes the consequences of that, which can also have a bunch of these hidden assumptions in them. And so you end up with parameters about agent decision making, possibly, I don't know, I'm assuming things like risk tolerances and other aspects that show up in economic decision making. And then you have parameters about how the world works, and then you have a stitching of them together. And so in order to do an actual like robust study of the phenomena, you would want to sweep both over the collection of parameters that are relevant to the agent decision making and over the parameters or functional forms that are representative of your assumptions, and then look at under what circumstances your conclusions hold up. And I usually refer to this as a failure mode analysis, because I'm, again, in a design paradigm, I'm like, what has to go wrong in my assumptions before my conclusion stops being true? And I'm usually, from this robust optimization perspective, like actually just trying to make a really big bubble where like, yeah, it's more or less good enough most of the time, but with a wide range of variation in the parameter assumptions of any agents, and over the like kind of world model assumptions of anything that I know that I don't actually know.
You're very much anticipating the direction that we want to go in, and specifically want to go in by designing this, what Sebastian is interestingly calling markup language. So concretely, what we want to do is to say, okay, the real setup of the model is that relative risk aversion is between 2 and 4. And the magnitude of the permanent shocks, the variance is somewhere between 0.05 and 0.15 or something. And then you'll have kind of a baseline value of the parameters, but we want to be able to automate the process of doing the kind of robustness testing that is usually not meaningfully done in the current practice, but ought to be.
Yeah. So I think I'm in the exact inverse of you, which is where, like, because I don't have the papers, but I have the like design, the need to be the person who signs off on designs, I'm like pushing for these very formal kind of, we call it parameter selection under uncertainty if we're actually trying to choose a parameter so we have control over some things in a market design. But like these workflows that I'm describing we do them based on first principles with kind of ad hoc tools, also short some of the language that we need to do it in a standardized, reproducible, and more efficient way, more legible to others way. But rather than working backwards from the paper, what we need to publish, we're working backwards for what we need to sign off and hand something over. And the thing that's in the intersection is a lack of these more standard description and execution mechanism or like tools.
Mm-hmm.
Yeah, the layer is like a layer of abstraction that's kind of necessary to a lot of different things, like do robustness analysis or a bunch of different models, publish papers with a bunch of different, do replication across papers with different models in them or similar models in them, and that's kind of where we're hitting. But I think maybe your original point, Zargam, is that it's not, in my view, sort of coming into economics sort of as an outsider, the kinds of differences between levels of abstraction, I think you're talking about behavioral and something else. I might say like a functional versus a technical specification. Like those are not common in the way economists are trained. And to some extent, it's teasing apart those layers, which is going to make this work.
I think that's actually really spot on. I've found myself having to do this. It doesn't necessarily need to be 4 layers, but like when I look at my systems engineering stuff, we have conceptual architectures, we have functional architectures, we have logical architectures, and we have physical architectures. And they're related to each other, but they're actually different levels of abstraction, and they have different focuses. And most of the time when I'm dealing with whether it's client projects or like just like the general application of my methods and tools and training to problems in the kind of market and institution design space, inevitably the first thing I have to do is figure out how to get a mess of concepts from different levels of abstraction kind of oriented against each other so that it's workable.
Okay. May I continue? I've got just a few more slides that I think will help clarify.
Yeah, sorry.
Yeah, sure. Something that's happened recently, which is very cool, is that there are new sort of deep learning methods in economics that are making it possible to solve credibly much more high dimension problems. And this means that having a more expressive language for economic models may become more useful. We might see like more value out of it if it's hooked up to these new methods than it would have been, 5 years ago. And so to some extent, the iron is hot.
Mm-hmm.
Okay. Because there's better algorithms now, it's possible to solve more realistic and complex models. Compute is cheap and getting cheaper than it was, decades ago. So it's possible to do more complex models, to do fewer sort of shortcuts on approximation. And then it's also more possible now because we've got so much sort of openly available, well-designed software, modular open source software. We can move away from hard coding models to decoupling the model configuration from sort of the analysis and the algorithms used on those models. And that's a direction we're heading to as we're designing Park 1.0, which we're sort of building towards in this 0.x series. Okay. And among the principles of this modeling, which we have some amount of modularity. So we want to be able to say, here's a piece of a model that represents something in the world, like a consumer or a market. And we want to be able to compose these like Legos, blocks. Zargam, I know you love blocks. We're also liking blocks. So we've got a block. We probably mean something different by blocks, but we at least like the word. Okay. Another thing is that whatever this modeling language should be, it should be both human and machine readable. We want it to be, like JSON or YAML. So it's starting to look like in our sort of early implementations and prototypes, a kind of YAML, but with mathematical expressions. And then we want it to be kind of agnostic to the interpreter and the processor on as much as possible. So talking about the level of abstraction that this is hitting, we want to know what the sort of functionality around this language is, but we want it to be possible to implement it with, say, not just in Python, but also in Rust. That way we can do replication and benchmarking on different implementations of the language. Okay. Now, here's the point about, what do we want to call this? Is this a modeling language? Is it a domain-specific language? Is it a markup language? To some extent, GAMS, Dynair are domain-specific languages, which is a programming language for a specific domain. So a domain-specific language will be often, Turing complete. It will be able to do things like say, here, add up these numbers, etc. I forget who introduced the idea of markup language into this sort of the subject of this meeting, but it is an interesting concept. So, LaTeX and HTML are markup languages. Those are languages for saying, here's the structure and format of a document and the relationship between its parts. To some extent, it conveys the kind of lightweightedness that we're hoping to get out of this modeling language. We want this to be something that people can write in a structured way, and that the meaning of the different parts of that structure are clear. Another thing implied by markup language would be that there would be a way to turn that into a presentation that's appealing. So maybe you would write something in this modeling language and then render it through LaTeX or etc. to, I don't know, maybe like a nice curve note based web publication, etc. So maybe there's a use of the model definition which is more presentational, but then also compatible with a computational engine. And to some extent, we also are aware there's plenty of programming languages out there. We don't want to create a new programming language. So if we can do it in a format that is portable across programming languages, that's better. So that would be my argument for markup language as opposed to domain-specific language. But I'm not wedded to it, just a different set of ideas. Any thoughts on this before I sort of present some examples?
Well, there's a point that the people listening may not quite have absorbed, which is, well, they won't have known the history. My strong feeling about what's wrong with Dynair is that the structure of what you were allowed to say was basically governed by the things that the creators of Dynair knew how to solve. So you weren't allowed to say anything that they didn't already have a kind of pre-baked solution method for. And that has meant that they haven't bothered to write a general purpose framework for describing problems, any kind of a problem that you arbitrarily might want to solve, but instead have limited their syntax to the very narrow set of problems that there are kind of useful, universally understood algorithms for solving. And our idea is to take kind of the opposite track, which is to say we want to be able to describe any problem within a certain class of problems that encompass, 95% of what economists do. And worry about whether something that you have expressed can actually be solved at a later stage. And so that's why the idea of calling it a markup language, it's like you're marking up your math instead of marking up your or you're marking up your formal description of what your problem is, rather than marking up the text. But of course, an appealing thing about that is that if you have a markup language in which the math and the structure of the problem have already been fully articulated, then that is the natural thing to use, not only for your slides, but even for the final paper, is to have the description of the model turns into nice looking math on the page, as a result of the math already having been sort of rigorously computationally defined in the markup language. So
that makes sense. I want to just make a comment then. I made an allusion to it with some reference to some of my own team's work, but I want to stay on this topic, which is like there's a phase where you're doing, which is effectively mathematical writing, definitions, equations, etc. But like then there's a thing that kind of comes in the middle, which I'm going to call like a specking language, where in some sense you describe the phenomena of people only specking things they knew how to implement, not having a language for just specking things. And so if you go from the order of abstractions that Seb was alluding to earlier, I mean, you do have your I'll just call this like the paper realm, or the math that where you're actually doing the work and creating this representation. Then there's like an intermediate representation, which could be marked up in order to produce it. But if I imagine this as a markup language, what I'm thinking is like your domain is your LaTeX or your Markdown or whatever, the text with the math in it that's interpretable. Your codomain of that is a specking language. So a markup is a way of telling, taking a piece of, let's say, more flexible text to interpret it in a more structured way, which should land you in a specking language. And a specking language is something that you can potentially automate the development of components for, or in some other components you may have to put more manual effort in, depending on whether there are out-of-the-box components that satisfy those specs. But you get a nice breakage where you can grab the parts that you recognize and you can still produce let's say the bespoke parts that you need when your particular spec doesn't match to things where you have all the components you need off the shelf.
I think that's very close to what we're aiming for here.
Exactly. That's you're really kind of channeling us, or we're channeling you or something.
We might just be correlated with observations about the same underlying phenomena, and like our own independent experiences of those phenomena are it's good. It's really good validation, honestly, to see someone coming at it from a different perspective and finding a lot of the same core observations.
Exactly. That's right. Right. So the math part, we really have been sort of separating it into these two components. The math part might say, the domain of the of the state variable is from 0 to infinity. And the specking part would say, okay, we're going to represent that by a grid of log normally distributed points. And you get to choose, you know, there's going to be a default value that you choose 50 points that are distributed between between a minimum of 0 and a maximum of whatever your max is. So that's very much kind of what we have been trying to do, or the direction we've been trying to move in. Great.
Just one quick thought before the next slide. For the economics use case, as we said, some people, Dynair was reluctant to develop a way to describe a model that there wasn't a good way to solve. Remember, solving in this case means determining the behavior of the system when the agents are performing optimally or close to it. It is much easier to, like, the space of problems that we know how to simulate given sort of an arbitrary behavior that's given to the agents is much larger than the space of models that we know how to get that optimal behavior out of those agents. And so to some extent, we can still guarantee the thing that concerns me is what guarantees the semantics of the language. You need some implementation to say, okay, we know what these parts mean in coordination with each other, even if we don't know how to do the solving task. So to some extent, simulation is an easier thing that can be done to guarantee the semantics of the language to the extent that it's describing a system. And then we can then say, well, what are solution algorithms or techniques can then be applied?
So there's a thing about that, though. We got to keep in mind the difference between properties that are inherent in the structure, which goes back to the thing I said earlier about the structural decomposition of so there's like a spatiality to the information processes, looking at those in terms of like causal models in general. I won't go too far down that rabbit hole, but like some things are properties independent of the decision process. Some of them are properties that are really sensitive to the decision process. And it seems like a key feature of this specking language is that it has to be able to sufficiently capture the structure that you could at least publish or like assess and make claims about the relationship between the differences, the effects of structure versus the effects of the individual actor behavior.
I agree completely. Yeah, we want to distinguish those things.
Yeah. Okay. Sorry. Go ahead.
Yep. So here's an example of a block that represents kind of the core of a consumer's problem. And so on the left, we have some YAML, and on the right, we have kind of what this means. So we can say, okay, this is an agent. They kind of start the block with K resources. They experience an interest rate, R. They get an income, theta, which is an income shock that's log normally sampled. They then consume, knowing how much sort of market resources they have, M, and with an upper bound on how much they can consume, which is also M, they consume C. And this is a control variable, so they have a choice over it. And then they end the block with A, assets available, and they accrue some kind of utility. This is a constant relative risk aversion utility with some parameter rho here. Okay. So this is an example of something that we think about a lot in the economics case. There's a ton of variations on this. You can have permanent income shocks, you can have health risk, but this is kind of the sort of the kernel. People are eating down and then they earn back up. There's interest rates. Notice there is no strategy here. There's no optimal decision policy defined because it's not even well defined. This is just a unit of problem that with some other things can be composed into a problem. And there's a few things to notice. I mentioned it's YAML. The way it's written, all these expressions that are kind of look like math can be parsed by SymPy into expressions that can then be rendered into like Python lambdas. There's some JAX compatibility in the back end there. And then if there's variables that are not defined in the scope of that block, so R and CRA are not defined in that block, there's in our sort of prototypes, we have functionality. So it can look to a calibration dictionary that's also defined in YAML and find those variables in a different scope. So one thing that's coming up a lot as we sort of build towards this is the scope of the interpretation of these variables depends a bit on context. We would like as much as possible for things much like in a real programming language for the scope of a variable kind of assignment to be well defined within its block, its coding block. But sometimes you need to sort of reach out into either calibration dictionary or previous history. And so managing those kind of scope changes is while keeping it modular is something that has sort of come up quite a bit. Here's an example of a different block that complicates the consumer's problem. So here, the consumer chooses how much of their assets, alpha, a percentage of their assets, are going to put into the stock market versus a risk-free asset, so keeping it in cash. Right? But then the performance of the stock market is out of their control. That's another log normal shock here. So there's a few different things going on. This alpha action, it's being chosen even though the risky return is not in its information set. And this R can be set endogenously. Before, it was being set in this calibration library. But we want to be able to say, well, if we set that variable R in this other block scope, we now want this R to be referred to here in this block. And so there's ways to manage this, and it winds up feeling kind of intuitive as we sort of put it together. But these are sort of interesting aspects that we've ran into while trying to build this out. Once you have these blocks, you can then perhaps, this is sort of a pitch at how to sort of construct a well-defined problem out of these blocks. You can say, well, given this model, it has these blocks, consumption, portfolio, and you may have noticed in the consumption block, you started with K and then ended with A, and they're both sort of denominated in money. We need to sort of twist that back around in order to make a complete loop. So this twist sort of renames that variable so that in each time period, the problem recurs. And we can call in this calibration dictionary and say, well, you know what? We want to set this up as a dynamic problem, so repeated over time with a discount factor of beta at each step. And so this might be a way to set up an infinite horizon problem with discounting out of a bunch of components.
Just to be sure this is perfectly clear, the point is that A is the assets 1 nanosecond before the end of the period, and K is that same variable in the next period, like at the 1 nanosecond after the beginning of the next period.
That's right. That's right.
So that's how it becomes an infinite horizon problem.
This is your characterization of the dynamical system. This is how you close a loop. You're saying that this is what it means for the prior to become the posterior of a value. Yeah.
Yes.
And this hasn't been implemented, so this is totally up for this is an especially easy thing to tweak, but it's a design.
Just to drill down a little bit on an earlier discussion that I think was sort of left hanging a little bit. Our ambition, I briefly mentioned this, but it's worth emphasizing, is not unlimited. We don't expect to be able to create the universal Turing machine kind of thing that can represent any conceivable mathematical problem. We're limiting ourselves to problems that can be represented as Bellman equation types of problems. So that's what I meant when I said like 95% of what economists do is Bellman kinds, or is these kinds of problems. And that gives us a lot of structure that would be absent if we had kind of the protean task of any conceivable model wanting to represent it.
That makes sense. I do think that there's an interesting question with modularity, with this blocking, right? I'm going to kind of lean back on this Seb's observation that I love blocks, like modularity, composability. If we think about this block that you've described here, it is something that we could call a dynamic insofar as it like, again, closes the loop. It's not just any block of logic with some domain and some codomain where you have some information in and then it produces it outputs some information. This is particularly something that can iterate, into your comment about the Bellman equations at all. And I think the thing that is interesting here, which for better or worse, is also the thing I'm trying to solve for is how do I reliably express this family of objects made from wiring together a bunch of different blocks with domains and codomains and sort of strongly type checked wiring rules that assign things that like the ability to both produce a change in the world, say, make an observation of that change in the world, take a decision based on a private objective and render a choice, which is then broadcast back out onto that world and may collide with and interact with both processes in the world and other agents' decisions to result in continued updates to the world. But eventually you have to be able to organize, no matter how complex that dynamic game is, a mixed process is, it needs to close on itself in the sense that its outputs then are greater than or equal to the set of inputs required to run it again. And this is where we move into the realm of basically dynamical systems theory as defined over structs, right? Structures, not just numbers, but like objects of data. Because I think the other thing that is important here is that we've moved into a realm where it's no longer real valued fields that are necessarily the right characterization of the observations and the decisions, but more now anything that could be expressed as a data stream, has a schema or a structure. It may still require specifics, a typing, but it doesn't need to be numerical. And that's where some of the really interesting stuff is happening, I think, is at this boundary of moving beyond just real valued fields and on to more general data structures as being the state spaces, the observables, the decision things. And it seems to me that this approach is sufficiently general to deal with that. But I'm curious how you're thinking about kind of non-numerical values in this sort of in this dynamic.
We haven't thought about it very much. Economists haven't thought about it very much, but I think a nice example would be another domain where economists are sort of beginning to see the light is in the importance of if you want to say everything depends on people's expectations, which is certainly mathematically true in our models, maybe we ought to try to measure expectations in the real world. And so when you do that in the real world, you ask people questions and they say they are optimistic or they say they're pessimistic, or they give you a probability. Well, probability is a numerical thing, but they use words to describe their perceptions. And one thing that has not been done rigorously at all is to try to map how would an agent who had this particular value at a particular moment of time describe their world to a survey interviewer who knocked on the door and wanted to know their views. And so those would be kind of observable outputs from the unobservable true value function that could and would be observable, let's say, to the Fed as it makes its interest rate decisions. And then the Fed's decisions in turn influence people's values, and they influence what people are going to say on the next expectation survey.
I've been messing with some simulations that take advantage of LLMs and to use them as a sort of coordinate system transformation, like the fact that you can go from contextual information and some numerical data and say things like, imagine you're so-and-so, how would you describe such and such? But you can also invert it, because that things like GPT now have JSON formatter features that allow you to get structured data out if you know how to ask for it. And so you can also go the other way. And as an engineer, my mental model is increasingly viewing this as a coordinate systems thing. Different coordinate systems bring different things into focus, but you get effectively have a natural language coordinate system and you have numerical coordinate systems, which actually have different representations. Potentially, you know, non-deterministic transformations between coordinate systems cause some reason for concern, but like there's some really interesting stuff I think on the horizon, which I alluded to when I talked about non-numerical. Text is interesting, but also we have a lot of, if you work with ethnographers ever, you'll notice that they have really strict coding schemata, ways of taking natural language and turning it into data. So at least the ones that do things more analytically. And there's also a good evidence of that in the kind of political economic Ostrom school, where you look at things like the institutional grammar, where interviews and formal texts are coded into formal statements that satisfy certain structural rules. And so I am like kind of this feeling that this movement into computation is also inviting us to move beyond just, again, trying to reduce everything down to real valued fields, and actually working with some of these other data feeds as actual data about the systems, and potentially introducing them into our dynamical models.
I agree. That's not something we have given much thought to, but I can envision how. So the thing that Seb hasn't had time to talk about, and I don't know if it's on his slides, but is this thing you've alluded to a couple of times about how, well, you have to turn the actions of the individual people into what is kind of the global outcome. And we have some mechanisms. We've tried to design some general purpose mechanisms for that. And I could easily see those mechanisms we've designed as being the kind of thing that could take the survey responses and turn them into an index, which the Federal Reserve could use, and then to loop back on the next round of expectations and so on. So that's a cool
That makes
idea.
sense. I realize we're like at time, but like I want to riff on this for one more second, which is to say, when you're talking about the ways you're evaluating outcomes, the thing that I find most salient is just differentiating between like the trajectory level assessments, and like sort of like you can have things that you're computing kind of in the flow of a simulation, or that you're deriving at every point in time, or things that are calculated where the domain of the metric is a trajectory. And when the things that are, those are like assessments of the run, and in the context of being able to sweep assumptions, sweep design parameters, sweep decision parameters of the agents, etc. I think of those like features. And so then you get these features of an individual run, and then you get labels, which are the outputs of the evaluations of the trajectories. And so you can actually get a machine learning workable data set by, if you have a sufficiently robust and controlled simulation framework, that you're going to say, well, my parameter space was made up of all of these assumptions, choices, etc. My simulation generated a trajectory. Then my evaluation machinery generated a label, or either a loss function computed over the trajectory, or a label, or many. And then what you end up with is features and labels with a huge data set if you've run repeated experiments. And that's actually how you can get into things like the robust optimization workflows. You can get into the failure mode tests and stuff, because now you actually you've almost hidden your simulation. You've just said, it's produced for me these facts of the form, or really, samples of the form, since there's always going to be some random number generation in there, almost always. You get this like, given the following assumptions and results, and then over and over again, with some potentially contradicting each other because of maybe sensitivities in the metrics to the randomness, but you get this big data set, and that data set is admissible to a wide range of statistical and machine learning techniques in a way that is only possible because of the care in both the definition of the model and the control over its execution.
that all makes perfect sense to me, and it is consonant with the ways some things are already being done, but more things should be done in the future. So
All right. Well, this sounds like.
this has
Sorry
been
to cut you off, Chris. I've made Z the host. I have to jump to another call, but you guys can stick around for as long as you want.
okay.
Okay, I've just got like a few more slides to respond, I think, to one thing you were saying, Zargam. My sense is that doing this, what we're talking about, right, for just numerical domains, is hard. I think I mean, I've looked at your kind of categorical cybernetics related stuff. I understand where you're going with other kinds of data types. And I think that the issue of sort of doing proper type checking of the kind of the domains and codomains of these blocks is something we really have to think hard about, and maybe we could be building on that work. I would expect that sort of introducing sort of other sort of data structures in it's not likely to be something we're going to implement at some point soon, because right now our implementation is
that makes sense, Seb. I
quite
think
a bit to SymPy and needing to differentiate stuff. That said,
specking, but this is the point
let me
about the
finish.
specking language is that I
Let
don't
me
think we
finish.
need to.
Let me please let me finish. That said, one thing that we have, so we have sort of models that we've done, which sort of almost shell out from sort of the HARC economics environment into another program, and then get some data back from it. So I could imagine something like this having sort of a call to an external program that might be able to read other kinds of data sets and then sort of interpret the right numbers or measures from that and bring it back in. I could see that sort of on the, like, sort of literally kind of on the horizon of the scope of what we're talking about here in these sort of slides. And then and in general, something that I'll bring up is that we're interested in creating a kind of working group to develop the language. And so everything that, in my opinion, everything that's said that's sort of a limiting statement about what this could be is, I think, subject to, the evolution. That's really just a prediction of where this sort of social process of defined language might go. And so, certainly if you've got other kinds of things to talk about, maybe that conversation will come up in later versions of this.
That makes sense. The only thing I interrupted you there. I was just trying to take back to your comment earlier about specking language versus implementation, and the comments were less like go make HARC, make your software engine do all this stuff. But when we're talking about not just implementing a specking language that can spec the things you're prepared to implement, if you want that specking language to be kind of zoomed out one level of abstraction so you can spec something and then determine which tools are right for implementing it, or auto-generate or grab the right ones. I do actually feel pretty strongly that the specking language should live, shouldn't be tied to numerical values if possible. And
I would really enjoy seeing like a full presentation from you just saying what you mean by a specking language, because you've introduced that term and I don't understand it yet. It's just not a phrase I understand. So I'm not going to argue
there's an example in the chat.
I'll just
yeah, okay, that's fine. We'll
So,
come back to it.
So just a few more things about where we're sort of thinking about going. So I've given you some examples of YAML for a very basic set of problems. We know that there are more complicated problems kind of definitely in scope for the economics use case. One of them being aggregation of agents through a market. So what happens when all the agents are working? They contribute to the economy. There's returns on the economy. Those get distributed to those agents. Maybe there's a Cobb-Douglas equation in there. Maybe there's something more complicated in one of these models that I was talking about, where we sort of shell out to a different program. We have a whole sort of a double auction market that simulates the stock market that runs at a completely different time scale from these sorts of agents, right? Then we've got these sort of birth, aging, and mortality questions. It gets especially tricky, I think, if the population of agents changes in size over the course of the model, but we also have sort of income over the life cycle, health risks, etc. There are versions of these models that get more game theoretic as you have agents in different roles, operating strategically, kind of adversarially, or at least in misaligned ways. And there's a lot of work done on alternative forms of discounting. So you could have either time inconsistent preferences like hyperbolic discounting, and then there's also what happens if you have endogenous discount factors, like what if there's some condition that makes people look forward to the future less, right? Which can be related to mortality, but can be something else. So these are sorts of things that are kind of on the shorter term roadmap for what do we want to express. And my sort of proposed strategy for how to approach this, and this might also be interesting given what you were talking about in terms of specking language, is if we say that there's a particular class of models that we want to be able to express in the language, we should have some kind of mathematical sense of what is the design of those problems in a general way. And by way of having a kind of reference implementation, we can do a clean Python API for describing those models that goes into something which will simulate that sort of model, given an arbitrary decision rule, not a solver. Because remember, solving these models is what's hard. Sort of just knowing what the mechanics are and getting something that works to represent the problem is substantially easier. Right. And then once there's a clean Python API for representing it, then we can start talking about solution algorithms that work for that class of problems. And then we can extend the YAML parser so we can get a configuration of that model rather than writing Python. So we can sort of move from something that guarantees the semantics of what we're talking about to something that makes it into the language. Some people might think that's not the right way around. I'm curious how this sort of hits you, Zargan, with the kind of notion of a specking language. Like, since I understand the idea of getting away from the implementation, but also like, what does a specking language mean if there is no implementation?
So I think it's tricky what we mean by implementation as well. So the thing that I linked, which is obviously like a work in progress, but it's open source, called MSML, is what we call math spec modeling language, which is just it's effectively a way of articulating a bunch of things that were previously being written in natural language and drawings into a formal but not yet computable representation. So think like JSON structures, assigning the relationships and the dependencies between a different bunch of processes. So it's like for me, it's a step between the sort of more natural language, right? Like kind of mathematics, kind of feeling things out, writing it out. It's not necessarily a standard structure. It's not quite structural yet.
How is it different from like UML?
UML, well, for starters, tries to do everything. I think it might be possible to describe it as a subset of UML. I think Sean might have tried, the person who's the main author on this. But that's not the point, because the point is to meet a need within an engineering process, at least for me. And that need sounds like the one that you're describing. It's the same reason for being. I have a bunch of documents that are sort of pre-computational. They're like written. And then I have a sort of implied model structure that says like, hey, like there's a part of the model that takes information like this and turns it into information like that. When I say it articulates it or structures it, it puts it into a modular form, but I haven't necessarily filled all those modules in yet. So now Sean is also building some tools to try to like streamline and facilitate getting a first running executable from this. But the thing that was the requirements for me on the MSML stuff, at least, was that a stepping stone where my markdown documents and, lucid charts and the stuff that we're producing in our team sessions and with clients needs to get organized into something I can store in a Git repo and that can clearly articulate what must be present before something is computationally executable. So it's like a stepping stone between something like a paper and something like a simulation, where you could start to figure out, for example, where those assumptions are even going to be. So we talked earlier about, where do I even need to make assumptions? To get to a model that runs, I have to make an assumption. Within an MSML thing, I might actually end up just filling in some text that says, I need to make an assumption here. And like, you can iterate on it by filling those things in and increment them towards having specific specifications of logic that's executable. But you need like a spot for the step where you even just like figure out what's missing. Because a lot of the times, and I think this must be the case with papers as well, when you go to implement them, you're like, oh, there's some like logics that aren't in the paper that need to be there. And so you first express them, you identify their dependencies, what are they potentially reading from and writing to, and you start to like figure out something that is, again, I'm going to call it like pre-simulation. So you've got text on one side, you've got a simulation on the other, and you need a schemata, like a way of describing, all of the stuff you have and leaving room for the stuff that you don't have, so you can say things about what kinds of assumptions you might want to make, or start to flesh out those spaces of things you're going to need to either design or iterate through when you run a simulation. So, I mean, I realize this is kind of random, which is why I posted the link to the repo.
Yeah, I'll check it out. I'll check it out. I have, because I've been trying to present these slides. I haven't been looking at your.
Yeah, no worries.
I'll check it out.
I think there's just a lot of overlap in our interests, and like you guys
Yeah,
have,
for sure.
sounds like you have a bunch of initiatives trying to tease at these, and I have a bunch that are in parallel with different team members leading on different parts of it. And maybe I'll see if Sean wants to present at some point if people think that this spec language.
I would go to a presentation that you set up on this, and you could, in this space, it would be fun. I do wonder if yeah, I guess it's not. I'm trying to build an intuition based on stuff I've already kind of have access to, and it sounds like sort of interfaces for a bunch of classes in Java, but without the sort of classes implemented, so kind of the types of what goes in and what goes out, but without knowing kind of the mechanics on the inside.
Have you ever used any like modeling tools from like, I mean, not that I want to advertise for like, MathWorks, but like MATLAB, Simulink, all that machinery was built out for engineering workflows that include designing decision-making policies. And, a lot of the features, the capabilities of that, those systems are, I think, what we need. And some of that is being able to sketch things out and define them relationally, formally, in terms of dependencies, prior to the introduction of the logic, the executable logics. And so we're gesturing at that stage in the modeling process between the fuzzier stuff and the executable stuff, when you have inputs and outputs and sort of blocks that maybe don't have any formal logic yet, but you just have some semantic information about like, oh, like this is this kind of thing. And then that you iterate through that stage to get to things that are executable, and the needing for a place to actually do what I'm calling spec work, where you're iterating on that representation before overcommitting to filling in the logics, because in that iteration in the spec layer, you might be able to simplify or otherwise improve what you're doing without wasting cycles, potentially, overfitting, like designing logics that you don't end up needing or something like that.
I think we agree in spirit entirely, and we're talking about things that are so abstract that like the ways in which we might slice up this sort of abstract problem space might not be entirely the same, but I don't think it matters. I think we just have to like keep talking about this sort of stuff. Just to close up, because I know we're out of time and things, there's sort of these are the docs for hard components to it, and we want to establish a working group. And the question I wanted to ask in this kind of room is, would it make sense to, the OSSI, I guess this is an interest group, but not a working group. So we're interested in these topics. But to me, a working group is a little bit more deliberate in sort of having deliverables. And I wonder if OSI, I guess Jonathan already left, but there was a question I wanted to ask him: is it possible to start a working group with OSSI, or what is the other sort of what other organizations are possible to start working groups under that might sort of want to be an umbrella for this? That's my
Short answer is that I think it's probably the case that a working group is possible, but the question is going to be, what's the scope of the working group need to be to get people engaged? So like for me, and members of my team, I think we share, to your recent point, a lot of the core concepts and that we want to meet are almost completely the same. We may have some different priorities, and we also have a bunch of our own toolkits that we've developed and again, they're also imperfect, incomplete, and need to be iterated on. So they're not like better in any meaningful way. They're just tuned closer to our workflows. And it seems very clearly that this tool chain is tuned closer to your workflows, which makes them phenomenal for comparison to each other and to learn from. But I don't necessarily foresee people, like I'll use Sean as an example, like taking time off of developing out the MSML to develop against something else when he uses the MSML in his job. And so he's going to keep improving it in order to make his job easier. But there's so many learnings that could come from like looking at how our workflows are similar and different and potentially improve both software kits, as well as identifying places where there are components in common. Because part of what I'm thinking is that there's a minimum set of common components that would be super valuable. And in some ways, the success of what I'm calling a Specing layer language is to be agnostic to that so that the specific tools can be picked after the decisions that should be tool agnostic are made.
Well, since most of the people that we have in mind for wanting to work with on this sort of language are economists who want to talk to other economists, it might be that this isn't the right kind of venue for the working group, but I think certainly what you've been talking about is interesting. So maybe the right thing to do is to continue with the interest group until we kind of have a better sense of what we're talking about mutually.
Yeah, that makes sense. I'm curious, Chris, what are your thoughts on the direction of, and I'm going to say this broadly, like economics as a field's movement vis-a-vis, again, what I was describing earlier are just like the robotics and engineering methods to policy design and assessment, which I know are a different lineage, but it seems like it's trending towards more like the controls and robotic stuff.
Yeah, I mean, there's a long history to this in which economists were in the 1960s very keen on optimal control stuff. And there's a journal, the Journal of Economic Dynamics and Control, that was basically how do we use the old-fashioned control theory from the 1960s for our economic problems. And the JEDC is still going strong today. But the profession has moved strongly in the direction of doing those kinds of things, but has lost contact with the people who were their sort of colleagues in the 1960s, which is the control people and now roboticists and people like that. We've kind of grown into our own universe, which I think would benefit a lot from reconnecting with the sets of people who are descended from the same ancestry, so to speak. There is a lot of kind of percolating interest in bringing tools from AI and machine learning and other sources into so far mainly just the solution methods for our models. What I think is a particularly fascinating possibility is to use AI models in particular as directly a model of human decision-making as opposed to a method of solving a mathematical model. That has not really been done yet, but I'm hopeful that it will be done sometime soon. So the time is ripe, I think, for these two areas to kind of re-engage with each other.
Sounds good. I'm gonna have to run now. This has been a fascinating and enjoyable discussion. Thank you so much, Seb. I've really enjoyed learning from what the Econ Arc group, like related project is doing across multiple presentations. Like one last comment then for you, Chris, is just I think that this intersection is where a lot of my interests are. Like I backdoored into like econ is not my primary field. I'm a control systems engineer. I linked my PhD supervisor because he does a lot of work on things that are related to collective phenomena and economics. He's friends with Darren Acemoglu, I believe, which probably influences some of his areas of interest. But the long story short, my interest in this conversation is actually partially about like checking, like, okay, like what has percolated, what is percolating, and like how can the more controls related expertise, systems engineering stuff contribute. Certainly has informed my industry work. But if you want to have a conversation at some point just to kind of compare notes, I would love to just sort of like, actually take some notes from comparing notes.
No, I would enjoy that. I'd like to do that. One last thing to bring up, because it might actually be relevant in this context, is the Journal of Economic Dynamics and Control was sort of created in conjunction with the Society for Computational Economics long ago. And I am the incoming president of the Society for Computational Economics. And one of the things I would like to do in that role is have people from sort of adjacent fields doing interesting things come to our conference next year. That's something in particular we could talk about at a Zoom that we arrange sometime in the next week or two.
All right, sounds good. I'll look out for maybe I'll see if I can pull the email address and just shoot you one to set up a thread. Thanks again, everybody. This is awesome. I might talk to John about making these 90 minutes because I actually really like the format where there's a presentation and a discussion. We can talk about whether we'd prefer to hold more space for the speaker and then do questions, or just I personally really like the conversational style, but I don't want to impose that on everybody. But yeah, it's been great. And thank you guys for participating.
Thank you.
Okay, thank you, Zargan. I'll send you something
you.
about next with me. Set in the chat.
Great.
Bye-bye.
Okay. Bye.